Hello. So here the problem number 1, and in this problem we have to find the next node according in order approach. For example, we are given particular node and we have to find the next node according to in order rule. So, and it will be considered in a binary search tree. So, and we're not given a root node in the problem. We're just have a link also to its parents. So basically our class of tree node will look like as the following, with the data itself and the left, right, and parent nodes. So what in order success means? What in order traverse means. So for example, we have this binary search tree. So it means that the first always goes the left child, then the node itself, and then the right child. So for example, if we're given this node with a 3, we should return 4 as the next successor. And for example, if we are given like 1, so we should return 3 as the next successor. Or if we're given a 4, this node, so we should return a null because there is no like any other childs or any parents of 3. So of this node, like, and so how we're gonna do this? So for example, let's consider like this one also have like this node as a 2, and for example we're given this node like this input, which is 1. So in that case, we will always check if the node we're considering, we're given in the problem, have a right child. If it has, so we will just, for example, declare p variable, which will be equal to the right child of a node, of input node, and we will check if also this node has like its other child. So we will check, for example, if it has like left childs, like I don't know, maybe 1. Let's just write down the decimals. Let's consider that the node itself not integer but decimals or float numbers. Since it's binary search tree, the left child should be always less. So if our right child also have other childs like left, we'll go all the way down until we will reach the end when our left child will no longer have any left childs, and we will also declare result, which we will return at the end. So each time when we will move our left child, we will move our p-value, at the top there will be a result moving at the same time. So for example, p here, our result will be equal to p first, then we will move p down, then we will again make our result equal to p, then we will move p down, and once there will be no childs of the node, we'll just return result, meaning that it's next in order successor of a p. So in our case it's the success. Oh no, it will be make p will be equal to result. We will move our p to null, and once our p will be equal to null, we will return result because it will be the next successor, for example, of this given node. So otherwise, if for example we don't have like any right child, for example we are given this node, but we have, for example, the node from here, like let's consider another example. Like we have this tree, and we're given one, but we don't have a right child. In that case, we will check. So if our parent is not null, and if our parents left, like this one, parent left equal to input node, so in that case we'll just return parent of that node. But for example, we have this node and we're trying to find out the next successor of this node, then we should go up to the upper levels. In that case, we'll try to check until we will get like we'll find out the next successor of 2. For example, we don't have this. I will make our input value equal to our p variable. We will move our p to the up, and we will search until our p will be equal to p parent left. Once it will be equal, it means that we actually reach the top of that tree, not of the tree, but of this like structure, and in that case we'll just return this node, meaning that it's the successor of this input node. So how we're gonna do it, write down it in our code. So not tree node, but just node. In order successor. So we're given just one node, like x. I'm declaring one node result, which at the beginning will be equal to null. Then I'm declaring p node, which will be equal to x right. And if we have right child of that node, we will move all the way down until we will reach we are considering this case until we will reach the bottom of our right child. In that case, so we're moving our result always making it equal to our p, and we're moving our p always to the left. At the end, we will check if our result is not equal to null. In that case, we'll just return result. Otherwise, if we don't have right child of the input node, in that case we'll make our p equal to x itself. Then we will go all the way up. We're considering this case when we're input node is a 2. So we will just, until our P is not equal to null, we'll just move it until we will reach, so until our parent is not null and P parent left is equal to P. So once it's our P parent left will be equal to P itself, we'll just return parent of the P, because this is the input node, our P is here and our P parent left, so parent of a P is here, P parent, and our P parents left is equal to P, so meaning this is the next node of this input node. Until we will reach this point, we'll just move our P to the next up node, like P parent. If we will not able to find anything, we'll just turn null. So time complexity for this will be the number, the height of a tree. So in a best case, I think so it will be like order of log n. In worst case, it could be like all nodes, like if, for example, we have a tree like 1, 3, and 4. So, and for example, we're given number 1, so we'll go through all nodes. So it will, in worst case, it could be order of n, and space complexity will be like just constant because we're not defining any additional data structure.